Hey everyone! In this presentation, we're going to be talking about a shielded metal arc welding project in the horizontal position. This project is going to be comprised of a T-joint, a lap joint, a corner joint, and then some surface welds. We're also going to be using two different types of electrodes. We're going to be using E7018 and E6010. So let's take a quick look at the blueprint for this project. This is going to be a preview of what you'll be given in class. So you can see we've got the three different orthographic views and we've got the isometric view. We've got some weld callouts here, and so you can see the overall shape that the project is going to have, and you can start pinpointing where the T-joint is, where the lap joint is, where that corner joint is, and where those surface welds are going to be. And also listed on the blueprint are the electrodes that you're going to be using for these specific welds. And then if we switch over, here's what your actual project is going to look like once it's all said and done. And let's run through some of the stuff that you're going to be needing. So just to practice, you might need some scrap steel, some stuff out of the scrap bin just to practice on. Then I've got some good plates here for the actual welding. You're going to need some thick gauntlet style welding gloves. Then you're also going to need a wire brush just to brush off the welds or brush off the material. You're going to need a chipping hammer in order to chip the slide glare off of the weld once each weld has been completed. And then you're also going to need either some slip joint pliers or vice grips in order to handle the material. After we're welding this material, it's going to be really hot, so instead of grabbing it with your bare hands or even with your gloves, use something else. And then here's the first electrode. So we have our E6010. So this is a electrode that gives us deep penetration. And I'm only showing you the other end of the electrode to show that I am reusing some electrodes that some of our students used beforehand. So I don't like wasting material. I like to reuse stuff if possible. And then these other electrodes are our 7018 electrodes. And then don't forget your ground clamp. I always have students ask me, why can't I weld? Why can't I establish a welding arc? Well, most of the time it's because your ground clamp isn't hooked up. So make sure it's connected to the table. And then we've got our electrode holder. So they come in many different shapes, sizes, styles, but more or less they're all the same. You open up the jaws. One set of jaws, or one side is going to be smooth, the other one's going to have grooves. That way it can grip onto the welding electrode, and then you can also position it in the electrode holder at various angles, just depending on what you're welding, maybe what position are you welding in, all that kind of good stuff. All right, so skipping ahead, here I am just tack welding some pieces together. That way I don't have to keep shuffling parts around the table as I weld on them. I should note here that my welding machine is set to about 130 amps. So I set my machine to run the 7018 electrodes first. So these tack welds are going to be really hot. You'll be able to see that here in the video. And so if you need some practice with 7018, if you need to, no pun intended, break the rust off, just remember when we're doing surface welds or anything in horizontal, we're dragging the electrode. So we're going to have a drag angle. So we're pointing the electrode in the opposite direction of where we're traveling. So if I'm right-handed, I'm going from left to right. If you're left-handed, you're probably going to be going from right to left. And so here I'm just going to be laying down some surface welds with 7018 just to kind of demonstrate, a little bit of practice, just kind of getting back into the swing of things. So easy, simple, just stringer beads, no weaving, no oscillation, no nothing. Just set the electrode in there and then just let it burn in. That's pretty much all that I'm doing. I have a slight drag angle on it. My work angle is 90 or close to 90 as possible. So you can see that here. I also wanted to just show you this view of me welding, so that way if you haven't stick welded in a while, this gives you an idea of what the motions are supposed to look like. And here are those same 3 welds, but from a different angle, using my second camera to put sort of a filter shade lens on there just to darken the view, kind of get rid of all that bright light that's emitted by the welding arc, and try to give you a better view of the weld puddle. Unfortunately, sometimes this camera doesn't break through the smoke as well as I'd like it to, but I hope that nonetheless you get a better idea with this additional view of the weld. One thing that I hope you notice is my arc length. So my arc length is very short when I'm doing these stringer beads, and the rule of thumb is that your arc length should be 1 to 2 times the diameter or the size of the electrode. So I'm using 1/8 inch diameter electrodes here. So my arc length should be anywhere from 1/8 of an inch to 1/4 of an inch, and no more than that. And any less than that, you're taking the chance of sticking the electrode to the base metal. So I'm going to give you just a still shot here coming up. That way you can see the length of my arc length, and that way you'll know when you're welding. If you see anything longer than this, then you really need to start feeding that electrode in a little bit better, a little bit faster, more consistent to what your weld is actually doing. All right, and last weld. And of course, once you're done welding, you should always chip that slag off. Don't give the slag too much time to cool down, because then it's really going to stick to the surface of the weld and it's going to be a little bit more difficult to chip it off. Now, just because the tool is called a chipping hammer doesn't actually mean you use it like a hammer. In most cases, just give it some light pressure and, just give it a few love taps and that slag should break off with relative ease. And then once you chip it all off, go ahead and hit it with your wire brush just to kind of clean it up, and that'll allow us to look at the weld and see if there's anything that we can do to change our technique in order to get a more desirable weld. And here I'm just running 3 more stringer beads with 718. I upped my amperage to about 140 from 130, and the material that I'm welding is 1/2 inch steel plate. And these plates were left out overnight and during the early morning, so they're pretty cold. I didn't apply any preheat. So those first 3 welds, they were a little rough in my opinion. So I'm hoping that with the addition of a few extra amps, I'm able to lay down some better welds. So we'll see. Now for this third plate of surface welds, I'm switching over to the 6010. And with the 6010, we're going to change up our technique a little bit. And we're still technically doing stringers, but instead of just setting the electrode on the surface of the plate and just letting it melt in, we're going to have a little bit of a whippet motion. So think of laying down a nice tack weld, and then once you have your tack weld at a sufficient size, go ahead and whip the electrode forward just a tiny bit, maybe like 1/4 of an inch to like 3/8 of an inch, and then bring it back on that leading edge of that previous tack weld you just laid down. So that way every bit of weld you lay has some overlap think of stacking dimes, you know, for lack of better terms. So every time you whip forward, you're going to come back to that leading edge of that weld that you had just previously laid down. So that way, every single bit you add has overlap, and like I said, has that sort of stacked dime appearance. I should also mention here that I've dropped my amperage. So instead of welding at 140, I'm actually welding at, I believe these runs I'm doing at 70 amps. So as I'm welding, just look at the motions that I'm creating with my hands. I'm just whipping it back and forth, back and forth. I'm not going side to side, or in relation to how I'm sitting to the weldment. I'm not going forward and back. I'm just going side to side. My work angle is 90 degrees. I have, again, a slight drag angle, and I'm not long arcing. This electrode just gives us, you know, really deep penetration. So even at 70 amps, it puts off a lot of heat and a lot of light. So that's why it looks so bright. And then I should also mention that my arc length is going to be relatively short. So same thing. I want my arc length to be no more than like a quarter of an inch. All right, anything more than that, and all you're really doing is just superheating the surface of the metal. You're not actually penetrating deep beyond the surface. So you want to keep that arc length relatively short, but not to the point where you're sticking the electrode to the surface. Here are those same three welds, but from the second camera, so that way you can get a better look at the weld puddle, the arc, and a little bit more of the motion, as if you were to be looking at it from underneath the welding hood. Second shot, I'm going to speed up just a little bit. And in this third weld, I'm going to speed up even more just so we can kind of keep it moving. Alright, so when it comes to chipping off the slag after you've welded with an electrode like 6010, it really takes no effort, even less effort than chipping off 7018. So it's very brittle. You can almost kind of think of it as just this flaky layer of slag. You can kind of scrape your chipping hammer across the surface to remove most of it, and then honestly the rest of it comes off just by brushing it with the wire brush. All right, so after cleaning up those welds, let's go ahead and get a closer view at what they look like. So this first shot is going to be done with the use of a light, and then the second one is just the natural light of the booth. But pretty much overall, this is what your welds should look like. Let's start looking now at assembling the actual project. So we can start with the T-joint first. Some people are comfortable with holding that top plate with their hand while they tack weld it, others not so much. So here's just an example of how you can use a pair of vice grips to hold that top plate in the vertical position while you tack it. Just clamp those vice grips on one side and then kind of lean it down so that way one end is resting on the table, and more or less it's going to hold it in place for you. So I like to tack on the very edges of the joint so that way the tacks are not in the way of the weld. And then once you have your T-joint tacked together, you've got two spots where you can weld. So if the first time isn't so great, you've got the second one to go ahead and, hope for a better result. And so here I am just tacking my plates together. And in this view, I'm giving you two different shots. One with just with a simple shade lens, and the other one with just everything all at once with the bright light. I should note here that I am going back to 7018. So for the T-joint, we're going to be using 7018. I've bumped my amperage back up, but I am welding on somewhat thinner material. This is about 1/4 of an inch. So instead of welding at like 130 or even 140, I'm a little bit colder. So I'm about 120 on this, just so that way I'm not melting through, because I am going a little bit slower just for demonstration purposes. And just with the same way that we laid down those surface welds, this T-joint is going to be done with the stringer bead. Nothing fancy, no oscillation, no weaving. Just stick the electrode in there. Work angle should be a 90, or splitting the angle in half. And then our travel angle is going to have a slight drag. I have a little bit more drag, but that's just for demonstration purposes. And so you can see from start to finish, it's just one fluid movement. I'm going to go ahead and put down a weld on the second side just to show you that it's completely fine. However, I'm not going to be able to give you a shaded view from my secondary camera. I took away the shade lens setting to just show you that I'm resetting the material, and then I forgot to turn the shade back up. So unfortunately that view is super bright. You're not going to be able to see anything, but I'm still going to give you this so that way you can see the motion of it all. All right, so I've gone ahead and I've chipped the slag off. Now we're moving into the lap joint. So literally the lap joint is just if you were to take two pieces of metal, stack them on top of each other, and then offset them so that way there's a little bit of overlap. And so I've just taken one plate, placed it underneath the T-joint, and then made sure that there is enough overlap so that way when I place my weld on there, I've got enough room to where I'm not melting over the edge of that bottom plate. And then again, just for tacking the pieces together, I like to put the tacks on the side or as close to the sides as possible. That way I don't have any unnecessary buildup of material within the weld. I'm still using 7018. I am leaving my amperage where it's at. And I'm not changing my technique at all. It's going to be the same thing as how I did the T-joint. Just do a stringer bead in there. Nothing fancy. So because this is 1/4 of an inch, it's pretty easy for me to melt that the edge of that top plate. So my travel speed is a little bit slower here, so that way I'll be able to show you later on after I chip the slag how just by slowing down your travel speed you can melt over that top edge. Not saying that's good, not saying that's bad, just want to show you what a difference in travel speed can make. When I'm done with this, I'll flip it over, weld a little bit faster, and just to give you an idea of, something to compare it to. Okay, now let's move on to the corner joint. I think getting the corner joint tacked together and fitted properly is a little difficult for students that are just learning how to put corner joints together. But just watch this. There's not a whole lot to it. Just make sure that when your plates are meeting, they're actually meeting on their corners. That way you have enough room within that joint to put down a good sized bead and not have to worry about melting over either edge. And just like with all the other joints, I prefer to have my tack welds at the very edges so that way I'm not welding on top of anything if I don't need to. My first tack was a little light, or I yanked on it a little too hard trying to straighten out that part, so I ended up breaking that first tack. No worries, that's why they're tack welds. You can just go right in, redo them. And so once you've done that, you got a couple different options to weld this. You can sit it at the end of your work table so that way it's hanging off the edge, or you can sit it on top of something on your work table. Doesn't really matter so long as it remains in the horizontal position and you can, successfully weld it from start to finish. Okay, so now let's weld up this corner joint. Now we are switching over to 6010, so please remember to drop your amperage. If you happen to use the same settings from 718 on 6010, you're just going to melt right through that joint, and we want to avoid that. So make sure you drop your amperage, about 70, 75, depending on your technique, and same as always, drag angle, whippet motion, same thing like we were doing with the surface welds. If you can get that down, then this corner joint should be no problem. And as usual, once you're done welding, go ahead and chip off the slag, give it a good brush, and let's move on to the next part. Actually, real quick, before moving on to the next part, let's just go ahead and take a look at these 3 welds, so that way you know what you're looking for in your finished weld when you're actually putting this together. The next and final part of this project is just making sure that the plate that had your surface welds is tack welded to this project. So the project consists of the T-joint, the lap joint, the corner joint, and those surface welds. So all these pieces should be tacked together and turned in for one grade. You can find out where to tack weld that plate with the surface welds if you just glance back at that blueprint. However, if you just want to tack weld it to a different side, to the bottom, the top, whatever, just make sure that those surface welds are somehow attached to this project. That way all the welds can be seen at one time. Okay, last part, I promise you, last part of the video. Okay, so after watching everything that we've done so far, step by step, every single joint of the weld, this is just putting it all together in quote unquote real time. But of course, I've sped it up because this video is already long enough. So I put myself in your shoes. I got in the booth, I got all my material, and I'm just putting this project together as if I were in the class. So go ahead, take a look. This is what it's supposed to look like. And then one last view at the finished project. So this is the project that I just did, and I showed you in the very beginning of the video with the blueprint. And then this other image is, I guess you can say it's the total damage. So this is everything that I used in order to put this project together. So you can see a lot of these welding electrodes, I went down to the very stub. Others, not so much. I really stress material conservation. So if you find some 6010 electrodes that are still pretty long, you may not be able to get a full length weld out of them, but you can still use them for tack welds, all right? And even when it comes to welding actual plates together, if you find that your first couple welds don't go as you planned, well, flip that thing over, weld on the backside. Keep tacking pieces together and just weld as much as you can on each single piece instead of just grabbing brand new pieces, putting down one weld. Doesn't work out, you toss it, you grab more brand new material. No, always maintain that mindset of conservation, because all this stuff costs money, and if it's not costing you money, it's costing someone else money. So I get it. Practice as much as you can, but also make the best of the materials that we have, please. All right, and so that's it. I will see you in the next video.